Let's try to write the exponential searching algorithm using JavaScript right now. So inside the searching folder, I'm going to create a new file called exponential search.js. Okay, so I'll simply minimize the side nav and I'll create a new class called exponential search. Now we will define a function here. Let's say the function name is exponential search and it will take the array and the value that user has passed. So as part of the first step, what we need to do, we need to find the range, right? So for that, what we need to do, we will simply define a variable called start index, and we will start from the index 1 in the array. As long as the start index is less than the array dot length and whatever the value we have at the start index, if it is less than the value that user has passed, that means it will be available on the right side. So to move on to the right side, what we will do, we will simply update the start index equal to start index into 2. Okay, by the time we complete this loop, right, whatever the value we have in the start index, it will go on to a position where it will reach to the largest index in the array, which we can use for binary search as a maximum range. So now using this start index value, let's calculate the minimum or the starting index for the binary search and the maximum or the ending index for the binary search. For that, what we will do, let min will be, why use let, let's use const minimum or the starting index will be whatever the start index divided by 2. But division in the JavaScript can give us the floating point values, right? For that, I'm going to do math.floor of this, okay, which will basically give the whole numbers. Again, for the const max or the end index will be math.minimum of this start index value and the largest index in the array. I will explain you why you need to do this minimum here. Okay, let's assume that the array that we have given contains 6 values. Okay, after the second iteration into the loop, we have a start index value of 4. Okay, now if we whatever the value that user is searching could be available in the index 6, but if we multiply starting index with 2 again, we will get a new index of 8. But array has only 6 values, right? So the index or the value of 8 could lead us into array index out of bounds exception. So the largest value that we can pass for binary search will be the largest index inside the array. That could be array.length minus 1. So if just to handle the overflow case where the start index could lead us into array index out of bound exception, just to overcome that, we are making sure that we are passing whatever is the minimum value. If the start index is giving the valid value which is less than the length of the array, then we will obviously go ahead and that start index itself. Okay, just to handle this overflow case, we are using this math.min operation. Now all we have to do is, we have the start index and end index for the binary search, right? All we have to do is, we will have to call the binary search function now. So we have already implemented this binary search function previously, right? So let me just grab that piece of code onto this class and let me just paste it. Now, as part of the binary search implementation, since we are searching it on the entire array, we passed min or the starting index as 0, max or the ending index will be the length of the array minus 1. But in our case, we have calculated them. So we need to take them as part of function arguments itself. So I'm just going to remove those variables. I'll simply add min comma max as part of functional arguments itself. Now let me just call the binary search function by passing array, the value and the minimum which is available inside the start variable and max which is available inside the end variable. Okay, this binary search function will anyway will give us the valid index if the value is present inside the array, otherwise it will return -1, right? So I'm simply going to return whatever this function is going to return. Okay, so what exactly we did, as part of the first step, we found the range. Using that simple variable, we calculated the start and end, and on that we called the binary search function. Okay, this is how we actually implement the exponential searching algorithm. Now let's call this function by passing some values so that we can validate the results. Okay, so I have the sorted array values here, and let's say the value that I want to search is 3. Okay, now let me just create an object for const es equal to new exponential search. On this es dot, let me just call the exponential search function, and let me just pass the array and the value that I want to search, and let's just read the result into some variable called index. Let me just log this. Okay, now this exponential search class is available inside this file, right? And this file is inside searching folder. So I will simply do node searching / exponential search.js. Okay, we got some error. Okay, the variable name I defined it as min, so let me just modify it to min. Okay, let me just clear the console and let's call the same once again. So if you see here, I got the index 2. Basically index 2 contains a value of 3. Okay, similarly if I want to search a value, let's say 7, in that case if I call the same, I got the index 6 which has the value of 7. Let's say I want to search a value of 17. In that case -1 because it is not available. Let's say I want to search for the value -17, and it is also not available inside the array. Okay, this is how we actually implement the exponential searching algorithm on JavaScript.